Okay, we're continuing section 8.1. We're looking at the Pythagorean Theorem. So we just finished example 1. We were looking for the hypotenuse side. This is in fact the easier side to find using the Pythagorean Theorem. The reason why is because both of the known values are on one side with the unknown on the left-hand side. So there's no isolation required. So there's no steps to move variables around to isolate for one or the other. So we leave the d squared on one side, we sum both of the squares of the opposing two sides, and finally, once we have the sum, we take the square root, and we find out that the length of the hypotenuse is 37.5. Example 2, we're going to find the shorter side. So in this case, we have an example of looks like a ladder leaning against a wall. It says a 4-meter ladder against the wall so that its base is 1.4 meters from the wall. So this dimension here then would be 1.4. The ladder itself would be 4, and the unknown dimension is the height that the ladder is leaned up against the wall. So from here down to here. Okay. So what we can do is actually redraw that as a triangle. Here's our ladder length, 4 meters. Our distance from the wall, 1.4, and our unknown h. Okay. Careful not to confuse h with the hypotenuse, which in this case is opposite the 90-degree angle for 4 meters. Substituting those values into the Pythagorean theorem, we get 4 squared is equal to 1.4 squared plus h squared. We want to isolate for h, so what we can do is leave the h on the right-hand side and move the other numbers away. So this 1.4 squared becomes 1.96, and you minus that from 16 here. Once we do that, the final step is to take the square root to eliminate the square sign on the h. So square root of 14.04 is 3.7. So our height here is 3.7. It's always a good idea to go back to the original problem, look at the dimension, and make sure your answer makes sense. Okay? So you should see that this looks approximately to be 3.7 if that is 4. Should never have a side longer than the hypotenuse. Hypotenuse is always going to be the longest side. Nicholas?
So wouldn't that just be like doing just c squared minus either a squared or b squared equals the other, whichever other one you're calculating for?
Yes. Yeah. So Nicholas said, is this the same as taking c squared, your hypotenuse, minus the other side squared is equal to the side you're looking for? And that's correct. That's exactly what we've done here. You see in this step, Nicholas, this 1.96 comes over to the other side? Yeah, so it's the same thing. Yeah. Finally, example 3, calculate the area of a right triangle. So remember, area of a triangle is base times height divided by 2. So in this case, our base is unknown, our height is known, and our hypotenuse is known. So to get the unknown base, we need to use Pythagorean theorem. So again, solving for one of the shorter side lengths, we're going to use this formula and substitute the value of our knowns. So 11 is our hypotenuse, so 11 squared is equal to a squared plus b squared, b being this other side length here. So 11 squared minus 64. Solve for a is 7.5. Now that we have the base, we can use the area of a triangle formula to solve for the area. So 1/2 base times height. Any questions on this one? All right, pretty straightforward. Key concepts. The longest side of a right triangle is called the hypotenuse. We need to know that definition, of course. Pythagorean states that the square of the length of the hypotenuse, so c squared, is equal to the sum of the squares of the lengths of the other two shorter sides, a squared plus b squared. C squared is equal to a squared plus b squared. An algebraic model representing the Pythagorean theorem is c squared equals a squared plus b squared. C represents the length of the hypotenuse, A and B represents the length of the shorter side. Does it matter which one you call A and which one you call B? No. So just like it wouldn't matter if you said 3 plus 5 or 5 plus 3, doesn't matter the order, so it doesn't matter which one you call A or which one you call B. A doesn't have to be the shortest side, B doesn't have to be the shortest side, doesn't matter. You can use Pythagorean theorem to calculate the length of an unknown side of a triangle. So if we have two sides of any right angle triangle, we can find the third side using the Pythagorean theorem. Finally, you can calculate the area of the right triangle using the formula area is equal to 1/2 base times height in this orientation, right? If one of these dimensions is unknown, you use the hypotenuse, apply Pythagorean theorem, find the side, then use the area formula. Any questions?